In this video, we're going to discuss a specific type of quadratic word problems involving a projectile, something being launched, and we want to know when does the object reach the ground. So let's look at an example. Let's say we have the height of an object is represented by h of t is equal to negative 16t squared plus 64t. This is the path of a rocket, this equation. It looks something like that. Of course, we only graphed in the first quadrant because the t, the time, can only be positive, and h, the height, can also only be positive. We want to know what is this value over here. Notice that when it reaches the ground, the height value, the h value, is 0. So if we set h of t equal to 0, and we solve the equation for t, we'll be able to find the time when the height is 0, when the object reaches the ground. So let's do that. This is just a regular quadratic equation. We have it set equal to 0. Whenever we're solving an equation, a quadratic equation that's set equal to 0, the first thing we want to try to do is there a GCF, and there is. We could take out a t, so t times negative 16t squared divided by t is negative 16t. 64t divided by t is 64. And this whole thing is equal to 0. Now we have our two factors, and we want to set them each equal to 0. So t is equal to 0. That is not going to be our answer because t is equal to 0 is when the object was launched at time t is equal to 0. So that's not going to be when it fell, when it landed. Let's set the other factor equal to 0. So negative 16t plus 64 is equal to 0. Minus 64 minus 64. Negative 16t is equal to negative 64. We're going to divide away the negative 16 to get t alone. And t is equal to positive 4. Let's say times in seconds. At 4 seconds, this object reaches the ground. So that means that this red point over here is 4 seconds.